Good morning, class. We are doing physics, chapter number 7, electricity and magnetism. Now we are on this topic, conductors and insulators. Conductors, the substances which allow electricity to flow through them, are called conductors. I think you understand this line properly, children. Which allow electricity to flow through them, those substances are called conductors. All metals such as copper, aluminium, silver, iron, brass, steel are conductors. You must have read about metals in chemistry also, children. Also, human body allows electricity to flow through it, so it is also a conductor of electricity. Impure water is also a conductor of electricity. Now next comes insulators, children. The substances which do not allow electricity to flow through them are called insulators. Now some examples of insulators are cotton, rubber, plastic, wood, paper, glass, leather, distilled water, etc. Okay, class? Now this table is very important, children. Now here are given the examples of conductors and insulators. Okay, only difference between conductors and insulators is that they allow the electricity to pass through them, and they do not allow the electricity to pass through them. I hope it is clear. Now children, do you know when two different insulating objects, now you understand the meaning of insulating, children, are rubbed together, some electrons move from one object to the other. Now when you are rubbing two insulating objects, then what will happen, children? Some electrons will move from one object to the other, due to which they get charged. Due to which, children, they get charged. I hope this line is clear. The object losing electrons. Now when, again I would like to read for you. When two different insulating objects are rubbed, some electrons move from one object to another object. Okay, now these things create a charge on them. The object losing electrons becomes positively charged, and the object which gains electrons becomes negatively charged. Now one object give some electrons, and one object takes some electrons. Now one which is giving, it becomes positively charged, and one which is taking, it becomes negatively charged. For example, when a glass rod is rubbed on silk, children, glass becomes positively charged. It means glass rod has given some electrons, and silk gets negatively charged because electrons move from glass rod to silk. I hope this thing is clear. Now next thing comes, flow of charges constitutes current. Now when these charges flow, children, it constitutes what, children? Current, electricity. We know that if two bodies at different temperatures are kept in contact, heat flows from the body at a higher temperature to the body at lower temperature. This you have read in chapter number 5, heat also, children. This body is at 50 degree A, and this body B is at 20 degree. Now direction of flow of heat will be from A to B, from higher temperature body to lower temperature body. Understood the point? Direction of flow of heat will be from A to B. And both this flow of heat will be from A to B till when? Till both attain the same temperature. Till both the bodies attain the same temperature. Now this example I have just told you. Now one more is there. Similarly, there are two jars, A and B, and both are having water in them. Can you see, children? And it is given that the level of water in jar A is higher than the level of water in jar B. And you can see from the figure also, the level of water in jar A is more than that in B. Although jar B contains more volume of water than jar A. Also, children, there is more water in jar B than in jar A. But they are connected with this, okay, this pipe. On opening the stopcock, we find that water flows from jar A, in which water level is higher, to jar B, in which water level is lower. When we'll open this stopcock, children, what we notice, that water starts flowing from A to B. The flow of water continues, and it continues, children, till the levels of water in the two jars become equal, till their level becomes equal in both the jars. Similarly, same way, if we join two charged conductors, remember children, conductors, the electrons flow from a conductor having more electrons to the conductor having less or no electrons. Now there are two conductors, A or B. It is having more electrons, it is having less electrons, or it is having more or it is having less. That flow of electrons will be from higher to lower. The one which is having more electrons, it will give to another one. Till what time? Till the number of electrons in both the conductors becomes equal. Now one example is given here in 7.24. Can you see this figure, children? 7.24. Movement of electrons from an uncharged conductor to a positively charged conductor. Now a positively charged conductor A is joined to an uncharged conductor B by a metallic wire. In this, a positively charged conductor A, children, positively charged, it has having positive charge now, it is is joined to conductor B, but it is uncharged, it is having no charge on it, okay, by a metallic wire. Okay, the electrons move from uncharged conductor B to charged conductor A. Now children, the electrons will move from B to A, from uncharged conductor to charged conductor A. Why? To balance the deficit of electrons in the conductor A. To balance it. To balance this thing, the deficit of electrons in conductor A. Now this movement of electrons continues till both of them have equal number of electrons. Similarly, you can see this diagram 7.25. A negatively charged conductor A is joined to an uncharged conductor B, again by means of a metallic wire. This is a wire. The electrons this time move from the conductor A to the conductor B. A has got excess of electrons and B has got no electrons. है ना? This movement of electrons stops only when, children, the two conductors have equal number of electrons. Now third case comes, children, in figure 7.26. Here you can see a positively charged conductor A is joined to a negatively charged conductor B by again a metallic wire. The electrons will move from, children, conductor B to conductor A, because B is having excess of electrons and A is having deficit of electrons, until both the conductors acquire the same number of electrons. Okay. Now children, the moving electrons constitute an electric current. Just now you read na, the electrons move. So this moving only of electrons constitute an electric current. The direction of current is taken opposite to the direction of movement of electrons. And the direction of current, what we are going to take? The opposite to the direction of movement of electrons. Okay. To keep an electric current flowing, that is to keep the electrons moving between two conductors, it is necessary to maintain an excess of electrons on one conductor and deficit of electrons on the other conductor. Now if you want that the electric current should keep on flowing, then one should have excess of electrons, one conductor should have excess of electrons and other should have continuously a deficit of electrons. Now this is done in an electric cell by a chemical reaction. Now this can be done in an electric cell by chemical reaction in the electrolyte. Now all these things you will study in your higher classes also, but for now you just know this much. Okay class. Electrolyte which creates deficit of electrons on anode and excess of electrons on cathode. Now children, current is defined. Now this is the definition of current which you should know. It is defined as the rate of flow of charge. That is the amount of charge flowing in 1 second. Whatever the charge is flowing in 1 second, it is your current. It is measured in the unit ampere. Its unit is, children, ampere, and the symbol is capital A. It is named after the name of the scientist Ampere. Okay class, I hope this much is clear to you. Please read till here. Have a nice day.